In a couple weeks, Dr. Jeanette Mumford will provide guest lectures regarding statistical models for neuroimaging applications. However, as a preview, we'll briefly introduce you to this and how to implement a simple model in Fsl. Imagine you had collected 6 new T1 weighted data sets, 3 of which were from individuals who were diagnosed with autism, and 3 of which who are considered typically developing controls. One question we could ask is whether there are differences between those with autism and those considered typically developing. We will set up the design matrix and contrast vectors for running this statistical comparison and use Fsl to examine whether any group differences exist. Prior to running the analyses, we would have needed to run the processing steps covered in this lab, such as bias field correction, skull stripping, and registering to a template. However, we've already done this step for you, and we have 6, 3 ASD and 3 typically developing, T1 weighted images registered in MI space located in this group analysis folder. Navigate to this directory. We will use Fsl's randomize tool to run our image analysis. If you type randomize into the terminal window and hit enter, you will see that you'll see the list of different options available for running randomize. Notice to run randomize, we need to supply a single input, an output base name, a design matrix, and design contrast file. The input is an image. The input is an image that is an image with all 6 images merged together. This is also called a 4D file or 4D image. Fsl has a special command to do this called Fsl Merge. We'll use this in the next slide to create our input. The following Fsl Merge command can be used to create our 4D image. This command will create the image called merge data, which has the 6 T1 weighted data sets merged into a single file in the order specified with the command. This image will be our input for our statistical analysis. Next, we need to create the design matrix and contrast file. To set up the design matrix, open Fsl by typing Fsl into the terminal. You should get this window to pop up. Click on the miscellaneous button and then GLM setup. Click on time series design and change it to higher level, not / non-time series design. Change the number inputs to 6. Click on the wizard and click on two groups unpaired and put 3 into the number of subjects in the first group, as this corresponds to 3 individuals in our ASD group and 3 3 typically developing individuals. Click on process. Your design matrix should look something like this. Group A, which corresponds to our ASD group, has 3 individuals denoted by the 1s and 0s. Group B, which corresponds to our typically developing group, has, again, their order is denoted by the 0s and 1s. Now click on the Contrast and F-Test button and change contrast to 2, and be sure to set up the C1 and C2 contrast as follows. Contrast 1 corresponds to areas in the brain where Group A, our ASD group, is larger than Group B, our typically developing group. Contrast 2, on the other hand, corresponds to areas where Group B, our typically developing group, is larger than our Group A, our ASD group. Save the model by clicking Save and giving the model a name. Let's simply just call it GLM. When you save the model, it will generate a number of files. One of those files should be a picture of the design matrix and contrast in your picture of the contrast. Save this picture in your lab report. Now that we've created all the files needed to run the statistical comparison, we can run randomize to compare the ASD in typically developing subjects. The 4D Nifty input file you are created, it will serve as the input, the merge underscore data. The design matrix file was created when saving the model and is called glm.mat. And the contrast vector file was created when saving the model file and is called glm.con. To run randomize, use the following command. To save time, we'll only run 25 what's called permutations. Typically, it is necessary for this number to be higher, but again, because of time limitations, we'll only run this using 25. Once randomize finishes, open the following images. TSTAT1 based images correspond to the contrast where the ASD subjects are greater than the typically developing subjects. The TSTAT2 based images correspond to the contrast where TDC is greater than ASD. Include screenshots of each of these output images and describe the findings. Are there locations where ASD is greater than the typically developing controls, or where the typically developing controls are greater than ASD? If so, what is the interpretation of these findings? What are some limitations to these findings/study? Describe this in the discussion section of the lab report.